Okay, Eisenberg kiddos, this is your math lesson for Tuesday, April 7th. From your assignment doc, you're going to want to click here where it says vocabulary document and pull up the document that looks like this. You will also want to have your math book out and ready and go ahead and turn to page 851. You can pause now if you would like to do that. We're going to go ahead and start with the doc first because this is going over some vocabulary that we're going to need today. So today we're going to be studying a specific kind of shape, and we're going to be proving that we know what type of shape something is by using something called attributes. So attributes are just the parts of a shape that make it that shape. And these are some of the things we're going to be looking at today. If you want to, I'm going to be filling this in for you and all the answers will be here. But if you want to keep track of it for yourself, you could easily draw a 3-column chart in your notebook, and you can copy this straight into your notebook if that would be helpful for you. Totally up to you. So the first attribute we're going to be looking at today are the sides of the shape. And so the definition of a side are the lines surrounding a figure. So you see here we have this line in red. That is one side of the shape. There's another. Okay, so we're going to be looking at the sides on a shape, the number of sides, and also how those sides interact with each other. The next vocabulary word is the word vertex. Okay, vertex is basically a math word for corners. Okay, so the place where two sides meet and form an angle. Okay, so see how this side joins with this side, and that makes a corner or a vertex. Okay, so this shape actually has 1, 2, 3, 4, 5, 6 vertices. So if there's more than one, we say vertices instead of vertexes. Okay. Next thing we want to know is angles. And we talked a little bit about these yesterday, deciding if they were greater than, less than, or equal to a right angle. And it says a figure that is formed when two rays have the same, and the word we want to put there is end point. So that means that this side joins with this side in the same spot. They join right here, and that creates an angle. And that angle is just the space in between those sides. Okay. Next one, right angle. So we need to be able to decide if an angle is a right angle or not. So remember that right angles form a square corner. So you can see we've got a square corner on this shape. So they kind of look like a perfect L, or they make a square corner. Parallel lines. This one is new today. So in order for lines to be parallel, they are lines that, sorry, I'm making some more space here, that never cross or touch each other. Okay, so lines that never ever cross or touch each other. Now here's what's tricky. Okay, so if you look here, you can tell that the top and bottom of this shape, even if I stretch this line as far as I could, and even if I stretch this line as far as I could, they would still be equally distant apart. And so they would never ever be able to touch. Okay, but if you look at this side and this side, if I kept stretching this one all the way up here and I stretched this one all the way up here, what would happen? Well, they would eventually cross or touch each other. So even though they're not touching right now, since they are kind of leaning toward each other, I know that if I stretch them out far enough, they would eventually cross or touch each other. Okay, so they are not parallel. The top and bottom of this shape are parallel. The other sides are not parallel because we could stretch them and make them touch. I'm going to go ahead and click over to your math page so you can go ahead and get your math book ready. Again, you should be on page 851, and the title of this lesson says quadrilaterals. So let's talk about that word really quickly. The word quadrilateral starts with the word part quad, and anytime you see that word part quad, that quad means four. So quadrilaterals are four-sided shapes, okay? So we're going to be talking about different types of quadrilaterals today, how we name quadrilaterals, and how we can prove that the name we give a quadrilateral is correct. At the top, they just help us remember what parallel means, and it says some quadrilaterals have sides that are parallel or equal distance apart, and that's going to be one of our rules for our shapes. So we got to remember to think about that parallel means that those sides will never ever touch no matter how far we stretch them. All right, so our first example, they have a picture of the Eiffel Tower over here, and you can see that they've highlighted the little shape right here. And it says the Eiffel Tower shown is in Paris, France. Describe whether any of the sides of the quadrilateral outlined in green are parallel. So remember, parallel means that they will never, ever, ever touch, no matter how far we stretch them. So it says the top and blank sides of the quadrilateral are parallel. Well, here's the top. And if I look at this shape, which sides will never ever touch the top? Well, this side is already touching. This side is already touching the top. So it must be the bottom. So the top and bottom sides of the quadrilateral are parallel. So you can fill in the word bottom right here. A quadrilateral with exactly one pair of parallel sides is called a trapezoid. So this shape right here is called a trapezoid because only one set of sides are parallel, okay? So if a quadrilateral, a four-sided shape, only has one set of sides that are parallel, then we call it a trapezoid. So the quadrilateral outlined in green is a trapezoid. So you can write the word trapezoid right here, and you can use it right here to spell. Some quadrilaterals have both pairs of opposite sides that are parallel. Those quadrilaterals are called parallelograms. So look here, this is a parallelogram. Notice how it has this little box that reminds you about the rules of parallelograms. That's going to be very important for your independent assignment today. So parallelograms, both pairs of opposite sides are parallel. So look, the top and the bottom are parallel to each other, and then the left side and the right side are parallel to each other, okay? So if I stretch this side all the way up, 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 and stretch this side all the way up, 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 they're always going to be leaning in the same direction, and they're never, ever going to be able to touch each other. Same thing with the top and bottom. If we stretch them out as far as we could, the top and the bottom will still never, ever be able to touch each other. Parallelograms also have to have opposite sides with the same length. So that means top and bottom have to be the same length, and the right and the left sides have to be the same length. Opposite angles have to be the same side. So look here. Here's one angle. That's a corner, right? This corner, this angle, is the exact same as this angle because they are opposite from each other. Same thing with the other angles. This angle here is exactly the same as this angle here. Okay, so that's what makes this a parallelogram. It has two sets of parallel sides, top and bottom, right and left. It has opposite sides that are equal length, top and bottom, right and left. And then opposite angles are also the same. So this angle matches this one. This angle matches this one. Go ahead and turn your page. Now, this next part wants us to get out a ruler and measure, but we're not going to take the time to do that right now. This side is talking about some other types of quadrilaterals, and some of these you should already be familiar with. Okay, so just by looking at the figures, which parallelograms have all sides that are equal in length? Okay, so that would be figure 2. all the sides are the same. And figure 3, all of the sides are the same length, okay? Which parallelograms have 4 right angles? Well, you can see we have squares in the corner of figure 1. So those are all right angles. And we have squares in the corner of figure 2. So those are all right angles as well. So a rectangle, which is figure 1, a rectangle is a parallelogram with 4 right angles. So any 4-sided shape that has 4 right angles can technically be called a rectangle, okay? A rhombus is a parallelogram with 4 equal sides. So the only rule about a rhombus is that all the sides have to be equal. Doesn't matter what the angles are doing. As long as all 4 sides are equal, it can be called a rhombus. A square is a parallelogram with 4 right angles and 4 equal sides. So in order for something to be called a square, all of the angles have to be the same and all of the sides have to be the same. So figure 1, you can see that there are 4 right angles, but notice how the top and bottom side are longer than the right and left. So that tells me that figure 1 is a rectangle, okay? So you would write rectangle here. Figure 1 is a rectangle. Figure 2, now this one's kind of cool. Figure 2 is a rectangle, a rhombus, and a square. So technically, since a square follows the rules of a rectangle because it has 4 right angles, and it follows the rules of a rhombus, which are 4 equal sides, a square is just a special kind of rectangle or rhombus, okay? So a square actually fits all of the rules for rectangle, rhombus, and square, but we give it the special name square. Figure 3 up here is a rhombus. Because it has opposite angles are the same, but not all of them are right angles. So that means that since it has equal sides, it is a rhombus, okay? Our guided practice says, refer to example 2, describe 3 attributes that figures 1 and 2 have in common. So let's look at 1 and 2. Well, I noticed that both figures have all right angles. I also noticed that both figures have 2 sets of parallel sides because the top and bottom of each figure are parallel and the right and left of each figure are parallel. Did it tell me to do 2 or 3? Yep, 3 attributes. All right. And the other thing I noticed is that they both have 4 sides. Okay, so that's using the attributes to describe a shape. You're just telling about angles and sides. All right, so let's go to the independent practice. It says check all the attributes that describe each quadrilateral. So let's look at the first one. It says opposite sides are equal length. Well, so here's a pair, top and bottom. So that's one pair. And then I also noticed that the right and left are equal length. So I would say both pairs. All 4 sides are not the same, so I don't want to check that. Then it says opposite sides are parallel. Is it just one pair of sides that are parallel or both pairs? Well, top and bottom are parallel. They will never touch. And then the right and left are parallel and they will never touch. So that's both pairs. Next, we're looking for right angles. They want to know how many right angles does this shape have? Well, I see 1, 2, 3, 4. So I would check that there are 4 sets of right angles. So since it has 2 pairs of opposite sides that are equal, both pairs are parallel, and it has 4 right angles, I would call this a rectangle. Okay, I'm not going to write the whole word because it'll take me forever to do it with my mouse. So I'm just going to put rec. That stands for rectangle. You go ahead and write the whole word. Okay, rectangle. Let's look at number 3. So opposite sides are equal length. I don't really see any sides that are equal length. Maybe this